Hello, everybody, and welcome to the fifth and final episode in our five-part cloud cost management series. Today, we are going to be talking about waste management in the cloud. And by that, we mean we're going to actually look at how to see what you have in the cloud, determine what may or may not be waste, and prevent unnecessary cloud costs. A little bit about myself to get started. I've been in this industry, the technology industry, for nearly 20 years now. Currently the director of DevSecOps at Yahara Software, where I oversee our DevOps, cybersecurity, and internal IT operations. Today is the fifth episode here, so today we're talking about waste management. We'll give it a start with a recap as always. So everything that we're doing here needs a strong foundation. Before we can start any of the work that we're talking about in these episodes, we need to start with a well-documented organization structure. People should understand where they sit within your organization, how their career is going to grow, who their stakeholders are and their customers, and what their responsibilities are within the organization. There should be a decision framework that clearly grants authority at different levels for different types of decisions, removing ambiguity of who makes what decisions, and ensuring decisions are made on a specified timeline. Create expectations and make sure there's no fear involved in decision making. Comprehensive style guides. A comprehensive style guide is incredibly important, especially in DevOps. One of the reasons we have so much cost and so much drift in our infrastructure is because we as an industry have not followed style guides. We have allowed engineers to code based on their own practices and their own experience, rather than setting clear foundation requirements for how code is written for DevOps. Having a good onboarding process is going to save your teams a lot of headaches and a lot of long-term costs. Having new engineers work through a 90-day plan that includes coding challenges, shadowing existing and experienced engineers, learning your style guides. Um, Oftentimes, failures on teams are not because the team isn't set up to succeed, but it's because an individual was added to a team or exists on a team who was left to fend for themselves and therefore was not able to succeed themselves, and that drags the entire team down. So once you've got your clear foundation set, you can start building out structure for your program. First off is to understand that data centers are actually microservices. They are not monoliths. Microservices were introduced into application development, but in reality, they actually work far better for infrastructure development than they do in applications. All infrastructure is natively discrete segmented components. A router is a router, a switch is a switch, a server is a server. These aren't things that know about each other. They aren't things that control each other. They are discrete segmented components. Data centers have been forced into monoliths by engineers over the decades. When we also have microservice, we get the power of reuse. Traditional IAC practices have pseudo reuse where people believe they're reusing code, but in reality, they're copying code from one repository to another and then customizing it. And then every single repository ends up being its own maintenance budget. Whereas truly reusable code written as microservices requires far less code lines of code maintained, prevents drift between environments and between projects, and allows true reuse of every line of module code that you write. So this becomes a problem because we are not operating in a green field. Most of us are sitting in an environment that has existed for at least 2 decades, if not longer, and has hundreds, if not thousands of entities in it that need to be converted into this methodology. And that is not an easy thing to do. There is a cost to this, and our customers do not want to tolerate outages. And if we can't do this without downtime, we're never going to succeed, not in an established environment. So this isn't something you can do overnight. This is something where you need to manage expectations and you need to maintain visible wins throughout your journey. And that starts, like I said, with a clear foundation. Document how you're going to do things. Template out your environment so you understand what you need and start building version controlled modules. Then move on to putting out how you're going to manage your projects. Put clear foundational project management techniques into practice. So, what are we really going to dig into today? So today we're going to dig into our FinOps challenges. And there are four primary challenges in FinOps. Number one is understanding what we have. So what do we have? Why do we have it? And what is the cost? And not just the dollar cost. What is the engineering time cost? What is the maintenance burden cost? What is that dollar cost? How much are we actually spending on hosting fees? But that's not all of it. We also need to understand what we need as an organization, because what we have is very rarely representative of what we actually need. We have to understand our cost trends over time. If we can't trend over time, we can't really do much with FinOps because we need to be able to understand what we're going to spend in the future if we want to be able to take proactive actions and controls to prevent unnecessary spending. And we need to understand how we can gate on approvals. So budget requirements need to be part of our change management process if we want to actually be successful in a FinOps organization. So what are the tools we can use for this? Well, the first and most obvious of these is our Cloud Cost Console. So Cloud Cost Consoles, AWS, GCP, Azure, they all have them. They work very similarly to each other, albeit with very different UIs. They have basically the same underlying functionality. So these consoles give us consolidated lists of our current state. This is the only place in the cloud where you can find a 100% list of everything you own. And the reason it's there is because you're paying for it. Everything that you're paying for is going to show up on your bill. That is the one place that you can reliably see everything that is in your cloud environment. It'll also provide some basic linear forecasting. This isn't very useful, but over time, it will become slightly more accurate. And as you're getting towards mid-month, you can usually get a pretty clear picture of what you're actually going to spend in that month. You can build out alerting on budget thresholds, and you can create rules that will temporarily disable resources in various cloud environments if budgets get exceeded. So we're going to talk a little bit more in depth about the alerting here, because that is the most impactful thing that we as FinOps professionals can get out of these cloud cost consoles. The first type of alert we can get is a savings plan alert. And I'm going to use AWS as examples here. The same concepts exist in Azure, GCP. They just have slightly different configuration screens. But you can do these exact same things in any cloud. So a savings plan alert is when you create an alert based on pre-configured savings plans where you're getting a percentage discount for compute or storage that you're using. So in the cloud, we have the construct of savings plans, which you can pay for in advance on a monthly basis. We're pre-purchasing discounted resources. In order for savings plans to be effective, you want to use as close to 100% as possible of your savings plan allocations. So we can create alerts on savings plans that will tell us if we are dropping below a given threshold. So this type of alert is a negative alert where we want 100% to be the goal. And if we're at 100%, there's potential for increasing your savings plan coverage. Excuse me. But if you're dropping below, for example, 90% or 75%, you may want to review whether or not the resources you're deploying are actually being covered by your savings plans. especially if you start at 95% coverage, which would be a great threshold to be at. And then you start to see that drop 95, 90, down to 80. Now you're going to start seeing alerts and you're going to want to look at that and say, hey, why is my savings plan no longer covering my infrastructure? Is it the wrong type of infrastructure for the plan? Is it infrastructure that's being deployed into a region that isn't covered by the plan? What is the case here, and how do we get that back into coverage so we can take advantage of those savings, those pre-purchased credits? The next one is a reservation utilization alert. Reservations are another cost-saving construct in cloud environments, which allow us to build out a given resource, for example, a database. And we know that database is going to be a long-lived resource, 1 to 5 years at least, right? So we can put a reservation in place to reduce the cost of that database by up to 50, sometimes 60%, depending on the length of your commitment. Those reservations are applied across any applicable resources in that cloud environment. So this particular alert is going to tell you if your reservations are not getting utilized, which is a common problem in cloud environments. So we build an RDS reservation, we apply that to US West 2, and then the development team builds an RDS instance, but they use a different version of RDS than what we reserved. So now we need to come back to that team and say, hey, that's great, you did it, but here's the reserve type that we have. Can you use this instead? We can use these alerts to help guide our implementation teams to use resources that we've already prepaid at a discounted rate. And finally, the third one that I'm going to talk about here is the monthly cost budget. These are dollar thresholds that you can set to say, if we go over $100, send me an alert and say, hey, your budget is now at $100. If I go over $1,000, send me another alert. Once we get to $10,000, start ringing the bells. Make sure we know that we're approaching these budget thresholds. These alerts are very useful and are much better than the linear projections that you get natively inside of cloud environments. Setting these up at thresholds and having them trigger at a given point in time. So if you normally are spending $100 by the end of your first week of the month, but for some reason this month now you're at $250 at the end of that first week, you're going to get the alert to say, hey, you're spending much faster than normal. Take a look at what you're doing out there and make sure that it's actually what you need to be doing. Next, we have data exports. So all cloud cost management consoles also have a data export functionality. AWS, they allow you to export theirs into Focus, which is a FinOps specific data structure. So we can build these scheduled exports. You can do the same thing in Azure. It comes out in a slightly different format. They just come out in a CSV format. But we can schedule these and we can have these sent out, and then these can be uploaded into other third-party tools. So if you have another FinOps tool that you're using to track your costs and you want to get more details into it than what it's natively pulling in, there's 68 data points on every single cost that you can export from an AWS cost management. There's a lot of data out there. So the next thing we're going to talk about here is FinOps and pipelines. And this is actually the more exciting part of this presentation. Because a lot of people have tools, a lot of people have the knowledge of the cloud and the cost management tools in the cloud. What most FinOps programs lack is a way to do predictive cost analysis before code is deployed. And so we're going to demonstrate a tool called InfraCost today. And this tool allows us to shift our cost analysis left in our development process. And we're actually going to implement it at the PR level. So every time a development team creates a pull request that affects the infrastructure that is deployed into our AWS environment, we are going to see the actual cost difference that that's going to create for our budgets. So this is going to bring visibility of the actual cost of ownership down to your development teams, which is going to help them make better decisions. One of the reasons development teams don't make great cost management decisions is because they just don't know. Most development teams never think about this because it's not in front of them. They think about their code, they think about their features, they think about what the customer is complaining about the loudest. They never think about the budget because the budget is something that somebody else is handling and they just assume that it's taken care of. But when you put something right in front of them inside of their pull request that says, hey, by the way, you're going to increase the cost of this by $700 a month. Are you sure that's what you need to do? They stop and they think. They really do because they actually care. They just need the information to be able to make informed decisions. This will also allow us to put gating in place on our pull requests. So if a pull request is going in that's going to affect an actual deployed environment, we can create gates that say, okay, well, you can't exceed a 10% increase in cost, or you cannot exceed a total cost threshold budget, total cost in your budget of $500 for your development environment, 5,000 for your production. And then we can automate those estimates so that future projects can be predictable. At Yahara, what we do is all of our templates run through an infra-cost pipeline when we design them. And then when a new client comes in and says, hey, I want to go into AWS, I want to use Fargate on ECS, I need an RDS database, I'm going to have a couple of S3 buckets out there, and we need this all running in a VPC with private networks and a load balancer and CloudFront distributions. I can pull up a template and say, okay, that is going to cost you X per month on the basic levels. And then as we increase utilization, the cost will go up from there. All right, so you should now be able to see Visual Studio on the left side of my screen and GitHub on the right side. So running through this, we have a very basic environment here. This is an environment with two EC2 instances, a load balancer, a VPC, and it's pulling in a Linux AMI that we maintain internally. So these are using our existing remote modules that we've written. We use those because it makes it easy for a development team to come in and make changes to their environment themselves. It makes it easy for them to understand what they need and to deploy things through code, which keeps them working in this pattern. Once things become difficult to do in code, people start making the changes in the console. Once changes are being made in the console, you can't track them in your pipeline, and your whole FinOps process for pre-deployment work breaks down. And that's why those foundations are so important. Because if our foundations are there, we can make this work so easy that nobody will want to do it in the console anymore. We have, let me actually look at this one first here. So we have the infracost YAML file here. So this is actually our pipeline definition inside of GitHub that is going to tell it anytime we're changing our Terraform files, rerun this, or if it's going against our main branch, rerun this and make sure our costs are not going to change. And if they are, report out what those changes are. So the first thing we're doing in here is we're actually checking out the main branch itself inside of the pipeline. We're doing a cost analysis on the main branch to get our baseline cost. Then we're going to do our cost analysis on the incoming branch in the PR. We're going to run a diff process on those two and use that to determine the cost increase or decrease. And then we're going to generate summaries for our pull requests, and we're going to compare it to our policies. And we're going to add the policy pass, fail, or warning to our pull request comments as well. With that, we have the actual policy here. So in this case for the demo, we have a pretty restrictive policy just to make sure that things trigger easily because this is a live demo and, because I like to live on the edge and take risks. So we've got our total cost So the total monthly cost cannot exceed $500. We have a threshold for increase in costs that cannot exceed $100 per change. We also have a percentage-based increase that says you cannot exceed 10% of the existing cost in your change. And this is an additional bonus here that you get from having a mature pipeline in your FinOps process, is that we can also do a cost decrease analysis. And that cost decrease analysis can help warn us if somebody is accidentally going to remove infrastructure that they shouldn't, which generally should never happen in production, right? That should be relatively locked down and people shouldn't be able to make manual changes there in the first place. But in development environments, people are constantly merging branches from different features in, pushing out to dev. If one person is on one commit, they push out, they get some new stuff out there, and then somebody else suddenly comes out and merges in an old commit for an old branch, and they push that out, there is a high probability that they could actually be merging code that will delete infrastructure that the team is relying on for testing new features. When that happens, yeah, there isn't an additional hard dollar cost in your cloud environment, but the cost of time to recover that development infrastructure is substantial. You have testers who can't do any testing. You have developers waiting on their environments to be rebuilt. You have the time it takes for the processes to run to rebuild whatever was torn down. Maybe it was a database. Maybe there's a new database for a new feature, and now the feature is deployed, but the database isn't, and everything's broken. But people don't necessarily know why right away. So now you also have the added cost of investigation. Your teams are going to sit there spinning their wheels trying to investigate what happened and why. Where if you had a check in your pipeline that said, hey, just so you know, you're going to be deleting something there, maybe you shouldn't do that. We can actually avoid a lot of that additional cost. And, I meant to mention this a little bit earlier, but one common misconception I get when I talk to executives and other business leaders about FinOps is that they believe FinOps is a process for reducing cost. And that is absolutely not true. FinOps is a process for ensuring responsible spending of your budget. We're going to make sure that whatever we spend the money on is appropriate, responsible, and going to help move the company forward. Yes, sometimes that means reducing cost, and it's great if we can. I've had clients where we've reduced their total cloud spend by over 40% by applying proper FinOps processes to their workflows. But I've also had clients where we actually increased their cost by applying proper FinOps processes because we realized that they were spending time troubleshooting problems that didn't need to exist, and that engineering time was actually more costly than the hard dollars in the cloud. And so by shifting their cloud environments to better handle resiliency and recovery efforts, we're able to save engineering time, which comes out as a net win for the customers. All right, so once we got these all defined, we can now start making some changes. So let's go ahead and make a change. I'm going to push it out, and we are going to see what happens in our GitHub actions. So let's do our first change is just going to be to extremely increase the cost here and see how much this costs. Never seen a 16XL compute optimized machine before. So let's see how much this will cost us. So we'll push that out. It's going to take a second here to come up. All right, our pipelines are now running. So you can see we've got several of our testing pipelines, which we built out during our foundational phase. We run on every PR that we create. We also have our FinOps pipelines here, which are right here. So let me just shift it. There it is, InfraCost. So it's running InfraCost right now. Check it started. It'll take a couple seconds here to complete. Looks like we're done. So you'll see I have this GitHub action up here. where we have just increased our costs by over $2,000 by changing that VM size. Now, if this information is not available, a developer may actually think that, 16XL, it's reasonable, it's what I need for my workflow because it's going to make my testing much faster. And I'm going to deploy that into my QA environment because that's what I think we need in production. But if they see, oh, that's going to cost $2,000 a month more, and here's the breakdown of where that cost is coming from, because you created that instance from a 2XL to a 16XL, they're going to think twice about it. They'll be responsible, generally speaking. Most developers actually are very cost conscious if they have the data in front of them. So this PR comment here is created by the workflow that we have. This is using the InfraCost free tier license. So this is actually logging in using their engine via an API key and CLI commands that are configured inside of GitHub Actions to build out this PR comment. And gating here, where you can see it says our policy have failed and we need to take action. Number one, our cost has increased by 334%, which is way over our 10% threshold. Our cost increase in dollars is over 2,000, which again is way over our $100 threshold. And our total monthly cost is now 2,600, which is way over our $500 threshold for this development environment. Now, InfraCost also does provide a paid side of their business, which comes with a GitHub application, which can do all of this for you. The difference is you do have to pay the licensing fees if you want to get the gating and the budget inside of your PR comments. So now the intention here is that our development team or whoever is doing FinOps for this particular development team, because we may, if depending on the organization, have a FinOps trained DevOps professional on the team, they can come back and say, hey, look, no, we can't do that. We need to go back. Let's find something a little more reasonable. Okay, let's bring that down to a 2XL. We're going to save that, and then we're going to rerun our pipeline. And we're going to see that it's going to resolve the issue. And so now our pipelines are running again. Okay, so it looks there we go. Almost there we go. All right, so now should see finish. Oh, something happened. Oh, I see what happened. So I go back. So we don't have a change from our original cost because I had originally it was the 2XL. However, our original cost is actually already over budget. So this is going to warn us that we're currently over our budget, but that's the existing cost of what we have. So what we need to do now is we need to take this back to our FinOps team and say, hey, look, here's what's going on. We've got a budget. We're exceeding the budget. This is the current status quo. We can't really reduce that. Can we have a conversation about the budget and see if we can increase that and get it over what we're actually spending? Because currently we're blocked on development. And in the development environment, probably wouldn't actually block anybody for this, but this is one of those things where it triggers a conversation about what's actually going to be spent on your development environments. And that's one of the key ways to get our FinOps process actually into the trenches and on the ground where our developers are working. If they can see, again, they need the data in front of them. If they can see that in front of them, that, hey, yeah, no, I'm already over budget now, then they'll have that conversation and we can have a really meaningful conversation with them about what that means. So now we're going to actually get this under budget. So we're going to make these both regular sized. 1XLs. And we're going to give it another 30 seconds here to run our pipelines. Now we can see we are back under our budgets. Our policies have passed, and we can see our estimation where we're saving that money. So now we can take this technology, we can take this process, we can plug it into all of our pipelines. We can set it up so that anytime we are deploying infrastructure code, we can now accurately and in real time estimate changes to our costs in our cloud environments before those changes are actually made in the cloud. We can use our cloud cost management tools to track actual changes and actual spend as it happens. We can report that granularly down to the hour. We can export daily reports into our other third-party tools that we use for our financial management. And we can create budgets and thresholds for alerting that tell us if we're not utilizing our savings plans properly, if our uh, reservations are going underutilized, and if we are exceeding dollar amounts within our cost thresholds for our budgets in the cloud. Once you have a mature pipeline like this that runs end to end, you can have real visibility into everything that you're spending, why you're spending it, and what your actual needs are that can drive increased cost. As we see these PRs coming through and as we see these financial gates being hit, we can accurately look at that and say, okay, I see that our development team is working on a new AI build out. I can see that they need to deploy a new virtual machine that's going to cost an additional $600 a month. And I can guide them on using something a little less expensive in development, maybe a moderate size machine in the QA, with the understanding that the QA testing is going to take a little longer maybe, and then put the full size machine into production so that we can help manage those costs throughout the development lifecycle and keep that data about the costs in front of our development teams so they can make better decisions about the impacts of the work they're doing. So that is what I've got. Get to the end here. The wrong button. Oops, too far. All right. Thank you all for attending this fifth and final session of my LinkedIn Live series. I appreciate all of your time. I really do hope that you learned something and have something you can take back to your own organizations and help your own FinOps processes to mature and get control over your clouds.